Okay, for the last one, we are being told by the directions to get like bases. So it says, like bases right here. It says salt, you use like bases. It tells me it all over the place. So I'm trying to get a like base between 1/4 and 32. And if I go look at my powers, can I write 4 as something? 4 raised to the something equals 32. No, that's not one of them. But 4 is 2 squared. So maybe 32 is on here. Here it is. So I can write each of them as 2 raised to the something. So I'm going to write this one as 2 to the 5th. But for the 1/4, remember that 1/4, I'm just going to write this to the side here. 1/4 is the same as 1/2 squared. But if I want to move it over the fraction line, I can do that with a negative exponent. So that's going to be the same as 2 to the negative 2. So I'm going to replace this 1/4 with a 2 to the negative 2, but I still have this outside of there. Exponent of x plus 3. And now I did rewrite this with like bases. I have a base of 2 and another base of 2. So remember that when you have exponents like this, a power raised to an exponent, you can multiply those. So I'm just going to set my exponents equal to each other. You don't have to write these words. I'm just writing them so that you know what I'm doing. Whoops. So then I have negative 2 parentheses x plus 3, or times the quantity x plus 3 equals 5. And then I'm just going to distribute and solve. And in the end, if I get a fraction, that's totally okay. So x is negative 11 over 2. And it's fine for me to have a negative exponent, so that's great. Okay. Then for number 2, this looks complicated because there's a lot of fractions, but I'm really going to look at, okay, I have fractions everywhere, and I have a 2/5 here. So can I rewrite this base of 25/4 as 2/5? So I know that 4 is just 2 squared, and I know that 25 is just 5 squared. So I'm just doing this like to the side here. This is just 5 squared over 2 squared, which I can rewrite as 5/2 squared. That's really close to 2/5. The only thing that I would have to change to make it a 2/5 instead is to make it raised to the negative 2, because that flips it. So 25/4 I can rewrite as 2/5 raised to the negative 2. And then I will put my 2x minus 3 on the outside of that. And on the left side, I have the 2/5 raised to the 3x. So I now have a common base of 2/5 for both sides. And so I can set my exponents equal to each other, knowing that I'm going to multiply right there. So now setting the exponents equal to each other, I am going to have 3x equals negative 2 times 2x minus 3. So when I do that, then I will distribute that negative 2, and then I'll add 4x to both sides. And then I'll just divide by 7. Again, it's totally fine to have a fraction. What you cannot have is a decimal. Okay, so x equals 6 over 7. And then for the last one, you know, number 2 had fractions for bases. I have a fraction here, but since it has a 1 in it, I think that I could just change it to a whole number base and use a negative exponent. So again, if you need to look at your powers to see what 3 and 1 over 27 and 9 have in common, you can, but the 3 kind of gives it away that, I think I'm just going to use 3. So I have 3 to the 2x, and then the 1 over 27, I can write as, let me just write all these down. Okay, so the 1 over 27, I know that 27 is 3 to the third. So to the side here, I can just say 1 over 27 is the same as 1 over 3 to the third, which is the same as 3 to the negative 3. That brings it up to the numerator. Just to show you how I'm getting from 1 over 27 to 3 raised to the negative 3. And then 9, you know, is just 3 squared. Okay, now I can't quite just set exponents equal to each other yet, because to set exponents equal to each other, I need to have a base. So I'm going to erase this just as a note over here. To set exponents equal to each other, I need to have the same base, but just like one base. Okay, I need to have one exponent, one power on one side equals same base power on the other side. Then I can do a equals m. But it's got to be just the one base. And so since I have 2 bases on the left side, I'm going to simplify this a little bit by putting this, let's see, this is to the 2x. This I can multiply and make it to the negative 12. And then I have a 3 here, and then raise the 2 times 6x minus 2. So all I did was kind of simplify a little bit, but I need to combine these into one base using the exponent rules that when you multiply powers, you add the exponents. So I'm going to have the same base, but I'm going to add the exponents, 2x plus negative 12. Now I have like bases, and now I can set those exponents equal to each other. So I have 2x minus 12 equals 2 times 6x minus 2. So that gives me, if I distribute that, that gives me 12x minus 4. And I will subtract 2x from both sides. And 4 to both sides. So negative 8 equals 10x. And then the last step is to not only divide, but also to simplify. So here I have x equals negative 8 over 10, but I do need to simplify that to negative 4 over 5. So that's my final answer. So I hope this helped.